Hey, Dr. Avinash here. This video is about an osmotic diuretic called as mannitol. Important to know. So let's talk about mannitol. Mannitol is pharmacologically inert. Now, what does this even mean? It means that by itself, mannitol can do nothing. The only thing it can do is just be present. Present in the blood, present in the filtrate. That's it. It just gets filtered. But by its mere presence, mannitol can actually exert an osmotic effect. The osmotic effect can be very well understood if you have understood the mechanism of making pickles. Whenever we make pickles, what do? We take the raw mangoes and we add salt to it. The moment we add salt, water starts coming out of the mangoes. Why does that happen? Because salt is osmotically active, it pulls water towards itself. Similarly, imagine mannitol present inside the renal tubular cells, inside the renal tubules, not the tubular cells. If it is in the lumen of the renal tubules, then it will hold on to water, it will pull water isoosmotically in the proximal tubule. That's one of the mechanism. By some unknown mechanism, it also inhibits the transport process in the thick ascending limb of loop of Henle. We don't know how this happens, but this definitely happens. The third thing it does is just by its presence, it expands the extracellular fluid volume. See, water cannot enter inside the cell. So water will pull out water. Sorry, let me reframe that. Mannitol cannot enter inside the cell. Now, because mannitol does not enter into the cell, it pulls out water from inside the cell. That's the reason why the volume, extracellular fluid volume, increases. This expanded extracellular fluid volume then enters into the kidney, GFR increases, and if GFR is good, then renin release will be lesser. Plus, it increases renal blood flow. Now the blood flow becomes so much that whatever we have discussed about the countercurrent mechanism, how the cortex is more dilute, the medulla is more concentrated because sodium potassium 2 chloride pump, that salt concentration variation, the corticomedullary gradient is gone. The salt is literally washed off. So the corticomedullary osmotic gradient disappears or gets dissipated because of this. Now, out of this four, if you have to pick one action, action number 2, inhibition of transport process in the thick ascending limb of loop of Henle by unknown mechanism, is probably the most important action. Important to remember also is the fact that osmotic diuretic mannitol is not absorbed orally and you have to give it as an injection only. Simple. It is available as a 10% and 20% solution and it can be given IV. Easy. Now, let's talk about the uses of mannitol. The uses are pretty easy to remember because it's very logical. By being in blood, mannitol can remove water from inside the cells. Similarly, it can remove water from inside the eyes, aqueous humor, and inside the brain. So wherever a person has increased intracranial tension or intraocular tension, intracranial tension ICT, intraocular tension is usually written as short form IOT. Both these cases we will prefer giving mannitol. Plus, in case of impending acute renal failure, you want to maintain GFR and urine flow, mannitol works fantastic. A more important function of mannitol would be to counteract low osmolarity of plasma and ECF when we do rapid hemodialysis or peritoneal dialysis. This is called as dialysis disequilibrium. So we can give mannitol to balance this out. A little side effect would be expected, like headache, nausea, vomiting. Sometimes hypersensitivity reactions do occur, okay, which are really minor side effects compared to what we are actually wanting from this particular drug. Okay, the functions are much more important, uses are much more important as compared to the side effects. I hope you have understood this particular answer. If yes, that's amazing. If you have any doubts, please let me know. I will be more than happy to help you. This is Dr. Avinash signing off for this session. Till the next time we meet, take care, keep rocking.